Hi. Okay, so we have section 28, applications of systems of linear equations. This is really important. You'll definitely see at least one question on the final exam over this information. So please make sure that you contact me, find me during office hours if you have any questions. So, learning objectives, solve general applications involving relationships between variables, solve mixing problems involving two simple interest accounts, and then solving mixing problems involving percent solutions. That's the chemistry version. But these two are very, very similar. Sorry for the shadows, y'all. I'll try to make it better. There we go. Maybe, hopefully. Okay, so we're just going to start with simple stuff. Write equations representing each sentence, indicate which variable represents what. So if we'll just say that A is Alyssa, M is Mike, if Alyssa had 10 more dollars than Mike, Alyssa had, that's like A equals. Had is, those are keywords for equals. So 10 more dollars, so 10 plus M. If we're say M is the amount of money that Mike had. So then A equals 10 plus M. So now if we have Marissa had 10 less dollars than Abe, so if M now is the amount of money Marissa has, A is equal to the money that Abe has. There we go. Then again, had M equals A minus 10, right? Less meaning subtraction. Oh, and of course up here, more meaning addition. So C, 20% of hummingbird feeder juice is sugar. So let me change colors actually. Let's see. If we say J is the amount of juice, um, then, and S is the amount of sugar, then S is equal to 0.2 times J, right? Because 20% of the juice is sugar. Is, again, is sugar, is equals to S. The tip left on a bill at a restaurant was 17.5%. So here we're saying that the tip is 17.5%. So if we have B, the amount of the bill, and T is the tip size, tip amount, there we go. Then here T is equal to 0.175 times B, because you go decimal to percent, right? So cobweb stuff here. Decimal percent, you move the decimal over two spots to the left. You always think Dr. Pepper, right? So if I'm going decimal to percent, I would move it two to the left, to the right, pardon me. Percent to decimal, you go two spaces to the left. Okay, so 17.5% is 0.175. So 17.5% times the bill amount is equal to the tip. Next, Sophia and Malik are planning to sell each of their sticker collections at a garage sale. Okay, so then we have, let's say, S for Sophia and M for Malik. If Malik has one more than three times the number of stickers for Sophia. Okay, so this is Sophia number of stickers. There must be some pretty cool stickers if they can sell it for money. All right, there we go. So again, we have Malik has. So M equals one more. So one plus three times the amount of stickers that Sophia has. Okay, so M equals 1 plus 3 times S. I give my S little feet just so that I know what's an S, what's a 5, right? So S, 5. If you have to make little notations for your S's and 5s, make sure that you do, because you do not want to get confused in your own handwriting, right? Your own calculations. And if I know that the total number of stickers is 113, then this says that S plus M is equal to 113. So now, look what we have. We have a system of equations. So what we can do is, again, remember, we really like it when we have an S column, an M column, and a number column. So we can just subtract this over to say, well, this is negative 3S plus M equaling 1, and S plus M equals 113. So if I run a negative 1 through the second equation, if this is equation 1, and I run a negative through equation 2, so now when we add down, what happens to the ends? They cancel. They cancel. So I now have that negative 4S equals, what is that? Negative 112. So Sophia has, let's see, mental math. No thanks. 4 goes into that, what, twice? Hang on, 112 divided by 4, 28. Y'all probably like shouting, it's 28. 28. So Sophia has 28 stickers. Yay. But are we done? No, not done. Let me scooch. We now have to go and find how many mallets have. But we know from either version of this, you can do this version, you can do this version. I mean, you can do any weird version of these. That's totally fine. So let's see. If I do just from here, 28 plus M equals 113, then M is equal to 113 minus 28. So Malik has 85. Ta-da! Your first kind of like application system, direct system. Hopefully it wasn't too bad. So we'll move right along into like our simple interest, our banking example. See if I can autofocus better. Ah, there we go. So remember that simple interest is I equals PRT, where P is the principal or the original amount. Original amount, remember R is the rate, but as a decimal. Decimal. And T is time, generally in years, unless otherwise noted. So if you take out a loan for $4,500 with 2% annual interest, how much interest will you owe after 5 years? How much in total will you have after 5 years? Okay, so I want you to pause the video and try this one on your own. And then when you're ready, just play. But really do, for real, try. Pretty please. Okay, so hopefully you've actually tried. So if I equals PRT, then this is 4,500 times 0.02. Remember, percent to decimal, you move the decimal over twice. Pew, pew. And 5 years. 5. That's it. You just grab your handy dandy. 4,500 times 0.02 times 5. I already forgot. Let's check. Perfect. 450. So remember, this is the interest I, right? So how much interest will I owe? We owe $450. But what will you pay back? Remember that is equal to what you borrowed plus your interest. So the accumulated amount or total amount, if you would, remember that has to be what you borrowed plus the interest you accumulated. That's the 4950, 4,950. Okay. Hopefully that wasn't too bad for you because we are now going to make it a system. We are going to have, excuse me, two banks with two different rates, and we have to find out how much is going into each bank. But the simple interest, this part right here, is kind of the heart of the problem. Okie dokie. So a retired woman has $50,000 to invest, but needs to make $6,000 a year from the investment to meet certain living expenses. One bond investment pays 15% annual interest. The rest of it she wants to put in a CD, which stands for certificate deposit, that pays 7%. How much was invested in each account? Okay, so here's the deal with these. This is how they will go down nearly every single time. You'll have two equations, okay? The first equation, I'm trying to get rid of the shadow. There we go. Maybe that's better, maybe it's worse, who knows? The first equation will describe the allotment of money. I mean, basically, it's usually like A plus B equals some amount, or W plus X, Y plus Z. Doesn't matter. But usually you're just saying, okay, some bank went to bank A, some went into bank B. That's really it. The second will describe your interest. Okay. That usually means the interest for A plus the interest for B equaling the total interest. Yeah, which in this case is the 6,000. Okay. And by interest, again, from up here, your I equaling PRT. Your I equaling PRT. That's how these go down every single time. Okay. So basically you'll have an A plus B equals the total amount. So in this case, 50,000. The next equation will have your interest from A plus your interest from B equaling your total interest. Don't reinvent the wheel, okay? I promise you this is how it falls into pieces. But I do want you to pause the video and see how far you can get. Even if it's just not very far, still pause and try pretty quick. Okay. So if I say we have $50,000 to spend, right? Interest from one bond and then CD. Okay, so I'll say B for bond at 15%, and then C for CD at 7%. Okay, so then I know that I put some money into the bond, some money into the CD, and we spent all $50,000, right? That is implied because it says the rest, right? So we know we put some into the bond, some into the CD, but we spent all 50,000 because it has the rest, right? All right, so here's equation one. Equation two, we are using, right, my I sub A. Again, this is PRT, this is PRT, right? Respectively for bank A or B in this case, the bond, and for the certificate deposit. So since I need to make 6,000 a year, that tells me that time T is 1. Okay. So really it's even less one variable we have to think about because T is 1. We just have to know what did we put in? What's the original amount into the bond? What's the original amount into the CD? And we have the rate, 15 and 7. So realistically, you just have the 0.15 into whatever we put into B, plus the 0.07, whatever we put into C, and we know that we are going to make, we have to, $6,000. So essentially notice your equation one, or I should say it this way, your equation two is equation one, but now you just have the percentages slapped onto it. Okay. So two is one, but with the respective percentages slapped onto it. That's it. And then from this point, you can do elimination slash addition, the substitution method. Let's practice substitution. You could even do graphing, honestly, actually, if we wanted to go crazy. Maybe I'll show you both. So if I just do simple substitution, if we solve for B, then B equals 50,000 minus C. So now I know that 0.15 times, what's B? B is 50,000, oops, excuse me, minus C. Plus 0.07 C has to equal 6,000, right? So all I did is that we substituted, right, what B equals in for equation two. Then we just distribute and solve. Okay, so, right, because we're solving for C. C is in parenthesis prison. Oh no. How do we get rid of parenthesis prison? By distributing the 15. So 50,000, 1, 2, 3, times 0.15 is the 7,500. 7,500 minus 0.15C, and then plus 0.07C equals 6,000. Now combining like terms. Let's see. So negative 0.15 plus 0.07 is a negative 0.08. C. And then that is a negative 1,500, right? Oh no, sorry. Yeah, 6,000 minus 7,500. Let's just make sure my brain's working. I hate these videos because I usually need y'all to catch my silly human errors. There we go, much better. Forgot how dark my screen was from class. Okay. And then the last step, what do we do to get C by itself? Yep, we divide. So divide by the negative, oops, slap in that negative. 0.08, sorry, you cannot see, whoopsie daisy. $18,750. And that is what we put into the CB. Okay, but are we done? No, now we have to go back and see what did we put in for B. Well, here's B. B is 50,000 minus C. So this is 50,000 minus the 18,750. 50,000, 1, 2, 3, minus the 18,750. 31,000. So B is equal to 31,251. Perfect. Yay! So one thing I will say is, right, make sure that you know exactly how much went into each bank. It's super easy to accidentally say, well, this is C, this is B, right? So don't accidentally do that because I can guarantee you, for the final exam, right, multiple choice, A might be that C equals this and B equals this. And answer choice B might be correct and have the correct respective how much goes into B and C. So just make sure that not only do you have to be careful when solving these types of things, but also make sure, especially in the homework as well, that you recall how much is going into which account, right? Super easy, just human error, most likely, that we accidentally just switch how much goes into which account. Okay. Almost done with these application questions, y'all. We're motoring through. Okay. A chemistry teacher needs to mix a 30% salt solution with a 70% salt solution to make 20 quarts of a 40% salt solution. How many quarts of each solution should the teacher mix to get the desired result? Okay, this, believe it or not, is the exact same as the bank question. Okay. So generally, of course, you'll have two equations. The first will describe the mixture amount. Like in this case, it's quarts. Okay. Usually that's like A plus B equals C. Like 3 quarts plus 2 quarts will equal 5 quarts, right? Whatever. In this case, since we need 20, it'll be like A plus B equals 20. The second will describe let's see, how did I do it? Well, it said interest. I'll say in this case, the salt percentage. Okay. So that is generally your percent as a decimal times A plus your percent as a decimal plus B equaling, in this case, we want the percent times how many quarts. So I know that's kind of hand wavy. Sorry, and I'm off screen. Apologize. But basically, this is what we have, right? So you have your very quintessential A plus B equals amount, and then your decimal times your A, your decimal times your B equals your purity of salt. Okay. So if I say that A is equal to my 30% solution, B is equal to my 70% solution, let's see, and then we need 20 quarts of 40%. That means we have, well, actually, you tell me, pause the video and see if you can get the respective 1 and 2 equation, and then come back when you're done. All right, so 1 is just A plus B equals 20. 2, essentially, you take A and then you just slap on the respective percents. That is it. So this is 0.3A plus 0.7B equals 0.4 times the 20. That is it. That is your equation. And then here we might say that 4 times your 20%, what is that, 8? Yes. So the only thing I would say is just maybe 0.3A plus 0.7B equals the 8. So now, if we have our two equations, we just did substitution elimination. Now we just did substitution. Now let's go with elimination. I will say that we will run I don't know, a negative 0.3 through equation 1. So negative 0.3 through equation 1 so that we eliminate A. So it's negative 0.3A minus negative or minus 0.0 or just 3 B equals, let's see, I'm just doing 0.3 at 6, but 0.3 times 20 is 6. And again, we are adding this just to the equation 2 so that we are eliminating A. We are adding just to plain equation 2 so that we are eliminating A. So again, note what happens to A by design. Yep, they cancel. And then this is just 0.4 because 7 minus 3 B, and that is equal to 14. Let me just check that my brain is making sure we're working. Yes. All right, so then to get B, we just divide by the 0.4. Divided by 0.4 is 35. In this case, quarts. But are we done? Nope. We need to see how many of the 30% solution we need. So A plus 35 has to equal to, oh, well, that doesn't make any sense now, does it? See how we know something is awry. 7, okay, 30%. I need a 20%. Uh-huh. Okay. 0.4 times the 20 is the 8. I'm sure y'all saw me do it a million years ago and you're screaming at me. But now let me find it. Well, first of all, how do I know this is wrong? Because if I only need 20 quarts, it doesn't make any sense that I need 35 quarts of B, right? That's not right. That's so silly. 40%. Let's just check our numbers. 0.4 times 20. Yep. 0.3. Oh, is that what it is? No. 0.3 times equation 1. No, yeah, okay. Is the 6 negative 0.3 negative 0.3 20 times. Oh, that's what it is. Negative. Again, I'm sure y'all were screaming at me. Forgive me. So that's a 2. That's a 2. There we go. So here we go. 2 divided by 0.4 is the 5. Much better. That makes more sense. There we go. 5. Okay. So then A is equal to 15. There we go. Okay. So 5 quarts of the 70 and then 15 quarts of the 30. And then always just kind of take a second to make sure that makes sense. Because basically you have 30% and you're trying to bring the dilution, the salt solution, up to the 40. You're just trying to use the more potent, if you would, 70%, so that it brings the 30% up that 10%, if that makes sense. Hopefully. Okay, we'll set up 6, but we won't necessarily solve it. Maybe I'll do that one solving by graphing, but I just want to practice. So, Community College Theater Department sold 3 kinds of tickets to its latest play production. The adult tickets were sold for 15, students sold for 10, and the child sold for $8. The theater department was thrilled to have sold 250 tickets and brought in $2,825 in one night. The number of student tickets sold is twice the number of adult tickets sold. How many of each type did the department sell? So this is actually a 3 by 3. Okay. 3 by 3 because we'll have 3 tickets, adult, student, and child. And then we'll have 3 equations. One that describes the money, one that describes how many tickets we sold, and one that describes the number of student tickets. Okay. So here, I just recommend go sentence by sentence. So A, let's say that's the number of adult, there we go. Tickets sold. If I could write. And then let's say we have S for number of student tickets, and then C for number of child sold. Y'all know what I mean. Number of adult tickets sold, number of student tickets sold, number of child tickets sold. So the adult tickets sold for 15. So 15A plus 10S and then 8C is equal to $2,825. Tickets total sold is 250. Right, so each of them have an A plus S plus C. The just A, S, C just represents the how many just tickets we sold. And then we have the one where it's with the money with how much each ticket cost, right? So like what was in the register at the end of the day, sort of deal. So then next, the number of student tickets sold is. So student tickets sold is. So S is. Twice the number of adult tickets sold. So it's just 2A. How many of each type did the department sell? Perfect. So here, what you'll do is you'll create a system, but you'll want your A column, your S column, your C column. So here you'll have 15A plus 10S plus 8C equals the 2,825. A plus S plus C equals 250. And then last, we're going to set that last one to 0. Let me scooch the page. So a negative 2A plus S. You can say plus 0 if you want, but you don't have to. Equals 0 plus 0 equals 0. And then you'll use what we learned from the 3 by 3 section to solve this, right? Basically, you're just doing substitution. Okay, and that is all of 28. Hang on, sorry, I always forget how to stop recording. Okay, I found it. Toodaloo.